Hello. Last section you have learned how to transform business requirements to truth table, then from truth table to Boolean equation, and transforming to Boolean equation helps in making the specification simpler and easier to wire the circuit. Also, this help in simplifying the Boolean equation. This time we'll learn specifically on how to simplify the transform Boolean equation using 5 axioms and 12 theorems in Boolean algebra. So specifically we'll learn Boolean algebra and why, because I have mentioned it is for us to simplify Boolean equations. And why do we have to simplify Boolean equation? Because we're gonna create simpler equation, which means it's gonna be easier to create the circuit. Because it's gonna involve less components, and also it's gonna be faster. It's gonna produce less heat. It's gonna produce less industrial waste. It's gonna be lighter. I mean, a lot of advantages if we could simplify the Boolean equation. Then specifically how, so we can use axioms. So what axioms are? Something that inherently true. Okay, we don't need to prove. It's just simply true. Then or everyone is gonna agree with that. And the theorems mean something that provable. We can use axiom to prove some or the theorems, or we can also use other theorems to prove the theorem that we are looking at. And one of the best and simplest way probably for the theorem with small number of input is to just simply prove that using truth table. If the two sides are having the same truth table, then they're going to be the same. Next, we'll learn some examples of how to use theorems to simplify Boolean equations. Now, this one is again axioms. We'll first start with axiom, and an axiom is an inherently true Boolean equation. So when we learn axiom, and also a theorem, we'll learn the axiom itself, and at the same time we'll have its dual form. So all the Boolean algebra, axiom, and theorems, they do almost all. They do have their form plus their dual form. So what does it mean is you just simply convert everything from n into or 1 into 0, and then you're gonna have its dual form. Okay, so if you see n, you're gonna convert it into or if you see 1, you're gonna convert it into 0, then you're gonna have its dual form. So probably it's just gonna help to just have to know one side of it, then we can easily transfer it to convert it into another side. So that is dual form. Then we will learn also what is the name of this axiom, and also why. For some other case, we may learn why is it important. But for axiom, it is inherently true. We'll say why is that inherently true, and everyone accepts that. So for the first one, axiom 1 is now if b equal to 0, if b is different from 1. Okay, or its dual form. If you see again 0, you convert into 1, and if you see 1, it's converted into 0. So its dual form is gonna be equal to 1 if b is different from 0, and this one is called the binary field. And why is this an axiom, or why is it true? Because one input can be 0 or 1 only. It cannot be both. Now another axiom is gonna be if it's not 0, then it is 1. Okay. Then its dual form is if it is not 1, then it is 0. Okay, then this one is a NOT gate by definitions, because we have only two values, 0 and 1, and by definition of the NOT operator, we'll have that. Okay, so this one is using not logical operator. Then the axiom A3 is specified as 0 and 0 is 0. Okay, so this one is its drawer form is 1 and 1, 1 or 1, or 1 plus 1 is 1. So this one is OR operator, not the plus operator. Okay, then this one is using AND OR. Then this one is using AND OR, or a logical operator will have that. The axiom A4 is if 1 and 1 is 1, and we convert them into its drawer form by simply, if you see n, you convert it into OR, and if you see 1, you convert it to 0, or if you see 0, convert it into 1. So 0 plus 0 equal to 0, and this plus sign means OR operators. Be really careful, because this one, 1 plus 1 equal to 1, doesn't sound right, but this one is the OR operator in Boolean algebra. We are taking Boolean algebra now. Okay, so this one we use AND OR logical operator, we have the same result. Then the next one is a 5. So you're gonna have 1 and 0 is the same as 0 and 1 is 0, and its drawer form will be 0 plus 1 plus 0, or 1 or 0 is the same as 0 or 1, which is 1. And this one also is AND OR logical operators will have this. Okay? So these are the 5 axioms that we have in order to use them to simplify our Boolean equation that we'll learn later. But we'll start with the most very simple one. That's why they are axiom. Now the next part we'll do is the theorems. So